Hello everyone, thank you for coming to this session. My name is François Michonneau. I'm the curriculum development lead at the Capntrees. My main day-to-day job is to take care of the current and future lessons that we're teaching at the Capntrees, but I also spend quite a bit of time on the infrastructure to make sure that our operations are running smoothly. And today I'm going to talk about some of our use case for using R in our operations. So the Capntrees is a nonprofit organization that teaches workshop. So we like to think of ourselves as a community of teachers and learners. The teachers are volunteers, and we are teaching workshops mostly to early career researchers and scientists all over the world. Our workshop usually lasts for 2 days, and we have 3 different flavors of workshop. Data carpentry, which focus mostly on the basic data skills, and we have domain-specific lessons, some on ecology, genomics, social sciences, and geospatial. We also have library carpentry, which tend to focus more on the community of librarians and other jobs in information-related roles. And finally, software carpentry, which was the first of the Capntrees, and tend to focus more on the best practices for developing software in scientific analysis. We have been running over 2,100 workshops since 2012. Most of these workshops are software carpentries. Maybe I can point this. But we are expecting the data carpentry curriculum to really take off with the increasing number of domain-specific lessons, and so we are going to run more of data carpentry workshops in the near future. The pool of instructors, the people who are teaching the workshops, again, are volunteers, but they go through a training program, what we call the instructor training program, and currently we have over 1,600 certified instructors that are teaching the workshops. We have been teaching workshops all over the globe. We have a strong focus in the US and Canada, and in Australia and the Great Britain because of the English-speaking countries. But we have been also teaching workshops in a lot of different places, including Antarctica a few years ago. All of this is managed by a staff of 10, so these are 9 of my colleagues. And so overall, we are a relatively small team to do the work we are doing. And so we are always trying to find better ways to try to manage our workflows, to be more efficient, and be able to teach even more workshops to even more people. So we are using R for reporting, so our annual reports, the report that we do on our assessments, and that's pretty typical. We use R Markdown for that. But today I'm going to talk more about these other use cases, how we use R for our lesson templates and creating our lessons that we have available online, the process of lesson publication, and I'll talk more about exactly what this means in a minute. And 2 other products that I recently developed that are not fully in production yet, but that will soon be. We try to be to practice what we are teaching, and so everything we are doing is open source and available on GitHub, or will soon be available on GitHub. If you have any questions, feel free to contact me. I have my Twitter handle at the bottom here, and my email address is also listed on the last slide. Feel free to come talk to me also until the end of the conference. I was afraid that it would be a little boring, a little bit dry to go through this laundry list of things. So I tried to limit the amount of details to keep it entertaining for general audience. But if you think I didn't provide enough detail, again, please come talk to me. So at the core of what we're doing, we're teaching workshops, we need lessons. Our lessons are available on GitHub. They are open, and we have a lot of people contributing to these lessons. We have maintainers who are responsible for the good functioning of the lesson and to manage the incoming pull requests and issues that people open on the repositories. For the lessons that are based on R, we have them as R Markdown files, and they get converted into Markdown file that get then picked up by using jcall to be rendered through GitHub pages. So the process I'm going to talk about is how someone who submits a pull request, like this one, where we added some text around how to specify the color of the points, in this case, on a ggplot graph, gets converted into the actual content of the lesson. So when someone do a change to the lesson on the master branch, either because a pull request was merged or the lesson maintainers who have right access to the repository make a change to the lesson, it gets picked up by Travis CI. As you would expect, the R Markdown file goes through the R Markdown package to get converted into Markdown files. This file then gets checked for spelling typos using the spelling package, which is one of the oprations packages. And then I'm testing this new package that I wrote called checker that is used to check links in static websites. All of this is orchestrated using the tick package, again, another oprations package, going through the process of review currently with oprations. And it's a great way to write in R the different steps that should happen on Travis. And so you don't have to edit both YAML file and R files. You can write everything as R. And it comes with really nice features. You don't have to mess with SSH keys or your GitHub personal authentication token. All of this is taken care directly by the package. And if you can also use it to generate package-done websites for your packages or publish your book-done books. And so when all of this happens, the checks are successful, then the rendered HTML file, or sorry, the MD file in this case, get pushed to the GH pages branch, again, thanks to the tick package, and then the lesson get are made available on GitHub. Again, so this is a checker package. It's still a little experimental, but if you think you have some interesting use cases, I would love to get some feedback, especially on the user interface and the kind of output that you are getting as a user. So our lessons have many contributors. Some of the older lessons have upward to 200 people who have submitted pull requests or edited the lessons. And because most of them are early career researchers, it's important for us to be able to provide a way to show their contributions. And so we are using a service called Zenodo to generate digital object identifiers, DOI, that the people who contributed can then use as a citation on their CV. Another benefit of using Zenodo is that it provides an archive of the repository, and it follows a really strict standard for archival, much stricter than what GitHub itself could provide. And in our case, because we use for most of our lesson a lesson template that is a different repository that we pull regularly inside the lesson template itself, the history of the lesson template and the lesson itself are intertwined. And so we are using the git log of each of these repository to extract the history, and then we use dplyr and other tools from the tidyverse to do an anti-join and only keep the contribution that are proper to the lesson itself. And so we can attribute contribution only to the lesson and not the template. The template itself will have a separate release process. Once we extract this information, we actually get from the git log only the name that the person provided when they set their Git account, or not GitHub, but their Git account on their laptop, and the email address. But this information is not necessarily the same as the one that we know from them. We have this internal database that we call AMI that stores information about the people who go through the instructor training, and that's most of the people who do the contributions to our lessons.
And so we use a GH package that is an interface to the GitHub interface to try to figure out who is the author of the commit, but by retrieving the GitHub username. And from that, we can see also if we can match them in our database, because it's also something that we have in the profile of our people in the AMI database. Once we have this cleaned up version of the list of contributor, we use another OpenSci package, ORCID, that will use the ORCID identifier. So it's a long series of numbers and letters that is used to identify people individually. And from them, we can retrieve their, the name that they would like to use when they're being cited on a scientific paper. We then create a JSON file that gets pushed to the repository, and from there, Zenodo will look at the metadata for this release and generate the DOI. So the way it looks like is that if we had 231 contributors on this particular lesson, then it gets converted into a nice list of actual names, and the little green circle here means that the ORCID ID is also recorded. And then there is a DOI available for this particular release of the lesson. Okay, I just wanted to, it was a lot of information, wanted to take a little cute pet break so we can get a fresh start for the next 2 items. Something that we get a lot in our workshops is that learners would like to have a certificate to show that they participated in one of our workshops. We've tried several things around how to test whether people actually learn something in our workshop, but we found that it was very hard to scale, it was demotivating, and it's not something we really wanted to do. So we used an approach more centered around just participating to a workshop. We wanted to do this to be as automated as possible, and we wanted to have a graphical interface. So people who are less technical as part of the staff, or people who are volunteering with us, didn't have to use a terminal to generate this certificate. So for this, I created a Shiny app. We also didn't want anyone to be able to generate certificates, so I put the Shiny app behind authentication using the Caddy software for servers. From there, we use our AMI database to retrieve the list of workshop, and then the user selects the workshop, upload a CSV file with the name and email addresses of the people who attended the particular workshop. We validate the email addresses that are being uploaded using the Mailgun API, and then we use the Magic package to pull the graphic elements that are going to go into the certificate, as well as the information provided by our database to create a learner certificate. And then we use the Mailgun API again to send the certificate to all the participants. All of this is written as a Docker file, and it runs on DigitalOcean, so it's very easy to deploy. This is what the interface looks like, and I'm just going to skip this. And just to show you the final product, so if Hadley was coming to one of our workshops, that would have happened at the conference, he would have gotten an email that looked like this, and this is all based, this is all composed using the Magic package. Finally, we are using, we want to, feedback is a very important part of our workshops. So before learners come to the workshop, we ask them to fill out a survey, and after the workshop, we ask them to fill out a different survey, and we share this information with the instructors who are teaching the particular workshop, but we also use this information as part of our general report to see how we are doing as an organization. But so the challenge here is that we only want to share the information that is specific to a particular workshop with a specific group of people. So I wanted a solution that was that limited what kind of information we could share, but not having to deal with creating accounts for the instructors, because we have so many workshops, it will be very time-consuming to do this. We also don't want to have to deal with a privacy issue that is to store email addresses or things like that. And we wanted to automate, again, the process as much as possible, because in the past, we were using something only based on SurveyMonkey, and there was a lot of manual steps. I think one of the staff members counted that it required 15 clicks on the SurveyMonkey interface for each workshop, so we wanted to do something a little better.
For this, we are using Typeform. The learners type their information using Typeform. We use Zapier to push the data to an Airtable. And then I have a Shiny app that every 15 minutes gets the data from Airtable, caches it on the server where the Shiny app is running. And then when the instructor visits the Shiny app, it provides in the URL the identifier of the workshop and a specific hash that we generate for them. And with this combination of the two, we can retrieve only the data for the workshop. Then we use dplyr and ggplot to generate the report. And again, it's a Docker container that runs on DigitalOcean. In the end, on the Shiny app, that's the kind of information we would get. A nice summary, easy to read for the instructor that they can get insight into who their learners are going to be. Overall, these exercises have shown how our ecosystem is great for that. We can leverage all the amazing tools that our OpenSci has been developing to interface with Web API. Shiny allows us to create quick graphical interface that non-technical staff member and other people in the organization can interact with. And having a common language to do all of this is very powerful because I can reuse the code that we use in our annual reports in our Shiny app to generate the graphics I just showed. If you'd like to learn more about the Capntrees or get involved, I put some links here, my email address, my Twitter account, and my GitHub account. Thank you very much, and I'll take some questions if we have time.
Any questions? No? So this one might throw you. You're storing data, yeah. GDPR and all that fun stuff. You know, you're dealing with people from around the world and you've got email addresses and information. How do you deal with that minefield?
It's something we are still working on. It's complicated, and we have been getting advice around different people. But we try to store as little information as possible on individual people that are attending our workshops, at least.